Welcome to the Q&A session 17 from the playlist of electromagnetic induction. The topic is the direction of induced current in a moving coil due to a current carrying conductor. So, based on this topic, I have selected one question for this session from one of my books, and the question here is: a square coil is moving with a velocity as shown in this figure. So this is the square coil and it is moving with a velocity v in the direction as indicated by this arrow. So we have to find the direction of the induced current in the coil due to the increasing current in this wire which is lying adjacent to the coil. So these two wires, this wire is lying adjacent to the coil, and this coil is moving with a velocity v in the direction as indicated by this arrow, and the current which is flowing in this wire is changing with time. Now, because of this current which is flowing in this wire, a magnetic field will be generated around this wire, and the direction of that magnetic field will be given by the right hand thumb rule. So as per the right hand thumb rule, the thumb points toward the direction of the current. So this is the direction of the current, that is the direction of the current is given by this arrow. So the thumb is pointing towards the direction of the current, and the curled fingers points toward the direction of the magnetic field. So here I have already drawn these cross marks. Now these cross marks indicate that the direction of the magnetic field is into the plane of the paper. These cross marks indicate that the direction of the magnetic field is into the plane of the paper, and it is given by the right hand thumb rule. The thumb indicates towards the direction of the current, and these curled fingers indicate the direction of the magnetic field. So from here you can see that the direction of the magnetic field is into the plane of the paper. Now we also know that the magnetic field due to this current carrying wire is inversely proportional to the separation of this wire and the point. Now, if the distance between the point and the wire increases, then the magnetic field will, we can say the intensity of the magnetic field will decrease. So since here the coil is moving in the direction as indicated by this arrow, so here the separation between the wire and the coil is increasing. So therefore the intensity of the magnetic field will decrease with time. And now, because the magnetic field is decreasing continuously with time, there will be a change in the magnetic flux with time, and because of the changing magnetic flux, an EMF will be induced in this square coil, and because of that induced EMF, an induced current will be also set up in the coil. Now the direction of the induced current will be given by the Lenz law. As per the Lenz law, the direction of the induced current will be such that it will oppose the change in the magnetic field due to the current which is flowing in this wire. Now here the magnetic field is continuously decreasing with time. So the direction of the magnetic field due to this induced current will try to reduce this decrement of the intensity of the magnetic field, and for that purpose the direction of the magnetic field due to this induced current will also be directed into the plane of the paper. So we all know that the magnetic field, the direction of the magnetic field is into the plane of the paper, if the direction of the current is clockwise. So in this case, the direction of the current will be clockwise as indicated by these arrows, because if the direction of the induced current is clockwise, then the direction of the magnetic field will be into the plane of the paper, and this will try to decrease the, or this will try to compensate the decrease in the magnetic field which is happening because of the movement of this square coil in the direction as indicated by this arrow. So the answer here is that the direction of the induced current will be clockwise. So thank you very much for joining this session. In the next session, I will be now discussing about the combination of the inductors, in which I will be discussing about the series and the parallel combination of inductors when they are placed very near to each other and when they are placed far away from each other. So till then, have a nice day. Bye.